Alright, so okay, we're kind of stuck. There's no more convenient values for x that we can use to get rid of all of our a and b terms, especially because our c and d terms are in the same product bunch. So what we have to do is plug in our known values for a and b, and then pick a reasonably convenient value for x. So then we'll have an equation in terms of c and d, and then we'll have to do that again, only with a different value of x. So then we'll have another equation in terms of c and d. So then we'll have two equations with two variables, which is solvable. So a good convenient value for x, well, let's just try x equals -1. Okay? Because the other ones we tried are x equals 1, x equals 0. So let's try x equals -1. So if x equals -1, we'll have 2 times -1 cubed. So 2 times -1 cubed, -1 cubed is -1, minus 4x, well, x is -1, so 4 times -1, minus 8 equals, a is 2. And x minus 1, that's going to be -1 minus 1, so that'll be -2, times -1 squared plus 4, well, that's 1 plus 4, so that's 5. And then that'll be plus b, which is -2, times x, which is -1, times x squared plus 4, which we already saw was 5. And then finally we're going to add this to c times -1, well, that's -c, plus d, and this is all times x, which is -1, times -1 minus 1, so that's -2. Okay? So this is all where x equals -1. So let's try, this is kind of a long string, but it's pretty basic. So 2 times -1, that's -2. -4 times -1, that's +4. Minus 8 equals 2 times -2 is -4, times 5 is -20, plus -2 times -1 is 2, times 5 is 10, plus -c plus d, -c plus d, times -1 times -2, so that's all times 2. So just take another step. Minus 2 plus 4, so that's plus 2, minus 8, so that's minus 6 equals -20 plus 10 is -10, plus 2 times -c plus d, plus d. Now, all these are factorable by 2, so let's just take a real quick factor 2 out of everything. So we'll have -3 equals -5 plus -c plus d. So let's get all our variables on one side and all our numbers on the other. So we'll add 5 to both sides, so we'll get 2 equals -c plus d. Alright? So this is one equation, so now we need to make another relation. So we're going to do that, only instead of -1, we're going to have x equals, say, let's pick another convenient value of x equals 2. Okay? So if x equals 2, a equals 2, and b equals -2, which we've found here, and we stated that x equals 2. Let's all plug them into our original equation here. So 2x cubed, that'd be 2 times 8, alright, minus 4 times 2, which would be 8, minus 8 equals a, which is 2, times 2 minus 1, which is 1, times 2 squared, which is 4 plus 4, which is 8, plus b, which is -2, times x, which is 2, times x squared plus 4, which is 8, plus cx 2c, so cx is c times 2, so that's 2c plus d times 2 times 2 minus 1, which is just 1. So let's try simplify this. So we have 16 minus 8 equals 16 plus, well, 16 times negative 2 is negative 32 plus 2 times 2c plus d. 2 times 2c plus d. Alright? And let's try to combine this again. So 16 minus 8, that's 0, equals 16 minus 32, that's negative 16, plus 2c plus d. So let's move 16 over, so we have 16 equals 2 times 2c plus d. And so let's divide both sides by 2, so we have 8 equals 2c plus d. Alright, now let's combine that with our original, or our previous relation that we came up with. So we'll have 2 equals negative c plus d, and well, we know how to solve this. It's a simple systems of equations. We can do elimination. So 8 minus 2 is 6 equals 2c minus negative c, so that'll be 2c plus c, so that's 3c, and d minus d, well, that's just 0. So if 6 equals 3c, divide both sides by 3, 2 equals c. Hey, it's pretty convenient. And let's plug that back into one of these relations up here. So let's plug it into this one. So we'll get 2 equals negative c, so that's negative 2 plus d. Add 2 to both sides, so we get 4 equals d. So now we know that a equals 2, b equals negative 2, c equals 2, and d equals 4. So let's go back to our original equation here. So a, like we said, equals 2. We showed that here. So a equals 2, so 2 over x plus b equals negative 2. Plus negative 2 over x minus 1 plus c and x equal 2 and 4 respectively. So this will be 2x plus 4 over x squared plus 4. And this is easily integrable. We think, oh wait, how are we going to do this? Well, the derivative of this isn't up here, but hey, we have a sum on the numerator, so we can split this into two different fractions. So we'll get 2 over x plus negative 2 over x minus 1 plus 2x over x squared plus 4, 2x over x squared plus 4 plus 4 over x squared plus 4. Alright? Now that's a simple, pretty simple to integrate. That's pretty simple to integrate. U substitution. Here we'd have to do another U substitution where we set u equal to our denominator. And then here we would have to use the arctan. But but all this is very integrable and very easy to do. So that's the final component to our partial fractions decomposition. So you should now have all the skills you need with some practice to decompose any decomposable partial fraction.